So we already discussed, we do not reject the null hypothesis, so we have to literally actually read B and D. So let's read and make a decision. Do we select B or D as in dog? B as in boy or D as in dog? Yes. Do not reject. There is not sufficient evidence to conclude that a higher proportion of subjects in group 1 experience drowsiness as a side effect than subjects in group 2. Do not reject. There is sufficient evidence to conclude that a higher proportion, of course, makes no sense. I think we have 5 more minutes. Let's see. Oh, yeah, that's a good one. Let's also compute a confidence interval. Yes. Construct a construct a confidence interval for P1 minus P2, given the level of confidence. Okay, very good.
Sorry to interrupt. Have I been muted this whole time?
I didn't hear you.
Oh, okay. Sorry about that.
Nothing to worry about. We
I
didn't.
was talking, and I guess.
No,
I
we
guess-
didn't. We didn't hear you. So I think you
Oh,
you
okay.
were muted. Everything is safe. So we have. We're asking what level 99. So they want 99%. And x1 is 33, and 1 is 252, x2 is 39, and n2 is 321. Good. Okay, so let's go back to stats and tests, and this time is a 2-proportion interval. So let's find 2-proportion z interval right here. Oops, I didn't mean that, I meant to go up. 2-proportion z interval, and x1 is 33, and n1 is 252, and x2 39, and 321, and they wanted 99%. Okay, and calculate. So negative 0.0627 and 0.08159. So this was for P1 minus P2. So let's put it in, and then I'll stop after I'll explain something. 99%, of course. Negative 0. Type an integer decimal rounded to 3 decimal places. 0.63. And the other one is 0.082. Okay, so I'll stop after this, but I want to record the problems that we did not complete so we can do them on Monday. So I want to explain something here very important. So see, this interval contains 0 because it starts at a negative value and it goes to a positive value. It cannot jump over 0, right? So, which means none of these two is consistently higher. Consistently higher would mean if P1 is higher, then the entire interval is positive. If P2 is higher, the entire interval will be negative. So none of these two is consistently higher than the other because 0 is in the interval. Because we can connect the confidence interval to the test of hypothesis. I'm sure we'll find problems that do that, make that connection. So please remember, every time we are looking at the difference of proportions or difference of means of two different populations, two different proportions or means, and the interval, the confidence interval we determined has 0 inside. It does, because this is negative and this is positive. Then we can never conclude that either one of them is higher. If it's consistently positive and it's only on positive values, this is higher. If it's on the negative values, then this is higher. But if it has 0 inside, we cannot conclude. We had that situation with some elections. We couldn't decide which one was winning because the difference had 0 inside. The interval had 0. We couldn't conclude whether this is better, higher, or this is higher. Okay, so that's